National 5 Maths, Practice Paper H, Paper 1. Now in question 12, it's a surge question. We've also got area of a rectangle. We've got to calculate the area of the rectangle. Now area is length times breadth, so we've just got to multiply these two things together. So A equals L times B. So length is 2 root 3, so it's going to be 2 root 3 times root 6. Now what we can do is we can split up the 6, because 6 isn't a prime number, 3 is a prime number, so we can't split that up at all. But we can say that is 2 root 3 times root 3 times root 2. So we split the 6 into the 3 and the 2. Now you should know that root 3 times root 3 is just 3. So that's going to be equal to 2 times 3 times root 2, which is therefore 6 root 2. In number 13, we've got to add together these two fractions. They've got different denominators, so we're going to have to give them the same denominator. Now, if you think about it, if you had something like 4 over 5 plus 1 over 2, you'd have to multiply the first fraction by that denominator. So you times the top by 2, bottom by 2, and you'd get 8 over 10. And then you times the second one by 5, top and bottom, and you get 5 over 10, same denominator. Well, it's the same kind of concept we've got to do here, only we don't have numerical denominators. So we're going to take the first fraction and we're going to multiply it top and bottom by that entire denominator there. So it's going to be 3 times m plus 1 over m times m plus 1. Now the second fraction, we're going to multiply this by that denominator. So it'll be 4m over m plus 1. Now combining the numerators, well, we could actually tidy it up first. Say that's 3m plus 3 plus the 4m over m plus 1. So we've got 3m and 4m is 7m plus 3 over m plus 1. Now you're going to get your full marks for that, but if you wrote it with the multiplied out denominator, that's okay as well, that's absolutely fine. So m times m would be m squared plus m times 1 is m, but I'd just leave my answer like that. And in question 14, last one in the paper, we've got to prove that the roots of the equation are real and irrational. So we're going to use the discriminant. So we've got 2x squared plus 8x plus 5. So that means the coefficient of x squared is a, the coefficient of x is b, and your constant is c. So therefore, b squared minus 4ac. Now it's telling us they're real and irrational, so we're expecting them to either be the same root or two different ones. It doesn't specify if they've got two distinct roots or it's just equal roots. We don't know that or not yet. So we'll find out in just a second. So b squared minus 4ac is going to be 8 squared minus 4 times a, which is 2, times c, which is 5. So it is 64 minus, so 4 2s are 8, 5s are 40, equals 24. So you can say, therefore, as b squared minus 4ac is greater than 0, there are two real distinct roots. So we've said real. Now we can also say that they are irrational. Now that's a bit more complicated, that bit, because notice it's 4 marks. Now that's not really a 4-mark question that we've just completed there. And irrational numbers are something you do learn about at this level, but it's not something that, from my experience, that a lot of pupils are like super confident about. So what's this irrational part then? Well, if you were to put that into the full quadratic equation, you'd get x equals negative b plus or minus root b squared minus 4ac all divided by 2a. Okay, remember b is 8 and a is 2. So that would give us negative 8 plus or minus the square root of 24 over 2 times 2. Now this bit isn't actually essential, I'm just doing that to help you to understand how this is working. You could still get the full marks with just a little comment just a minute ago. Now this bit here, the root 24, 24 is not a square number. So root 24 is a third, because root 24 is root 4 root 6, which is 2 root 6. So 2 root 6 is irrational. So therefore this entire thing of negative 8 plus or minus root 24 over 2 times 2, which would be 4, would just be negative 8 plus or minus 2 root 6 over 4. Even if you divided it all through by 2, just to simplify things a little bit, you get negative 4 plus or minus root 6 over 2. Because that is a third, you can't simplify it, you can't turn it into a square number or anything like that. You would get, that is irrational, you can't write it as a fraction, so therefore the whole thing is irrational. So going back to our comment, so therefore as b squared minus 4ac is greater than 0, there are two real irrational distinct roots. So hopefully that clears up the irrational part, which is a bit extra in this question compared to the nature of the roots questions that you usually see.